All right, friends. So today we have a daily quiz like usual. Don't forget you have 2 math Excels this week, one on Tuesday, one on Thursday. And we're going to talk today about the probability of multiple events happening. So what if we have more than one thing happening? So here we go, probability of multiple events. There are two types of situations. The first one is that if your two situations are completely independent, that means the first one doesn't affect the second one at all. So, for example, if you're flipping a coin and rolling a number cube, those two things are not going to affect each other at all. What you do on the coin is not going to affect what you do on the cube. The other situation is when your two events do affect each other, more so the first one affects the second one. So, for example, if you pick a card from your regular card deck and then you pick a second card, because when you have picked that first card, you now have one less card than you did before, that has affected the outcome for your second card. So, when you picked the first card, you had 52 cards to pick from. When you picked your second card, you only had 51 cards to pick from. Because the first one has affected how the outcome of the second one has changed, then that's a dependent event. So independent, the first event doesn't affect, and dependent, the second or first event does affect. Now, in addition to being independent and dependent, you have two options for independent. They can be mutually exclusive or not mutually exclusive. And that's when you're trying to decide if the outcomes overlap or not. So when you talk about mutually exclusive, your two events cannot happen at the same time. So for example, when we're picking that card out of the deck, you cannot choose a red card and a black card at the same time. However, if you're choosing one card, one red card, and you're choosing the card you chose is an even card, then you could have not mutually exclusive events. A red card could also be an even card. So once you get to independent, you want to ask yourself, can those two events happen at the same time? And you'll see that in the examples that we do. So how do we, once we've decided what kind of event, how do we calculate those? Well, there's a couple of different times. So first, if both events happen and they are independent, then we're going to have A times B. So that is if both of them are happening. Notice in the problem, it's an and. So this and that, okay? Once you get to or, then you have to decide if they're mutually exclusive. So these are still independent events, but if we are doing or and they are not mutually exclusive, you find the probabilities and add them and subtract what is happening when they both happen. If they are mutually exclusive, then you get to cut out that last part because they don't happen at the same time. That's the whole idea of mutually exclusive. So it's just taking the probabilities and adding them. So again, if it's an and situation, then you multiply. If it's an or situation, you're going to add. And if it's not mutually exclusive, you're also going to subtract what happens when both of those things occur. So you'll see both of those again in the examples. Okay, let's talk about independent versus dependent. So here's our first set of problems, and we just have to decide if they're independent or dependent. So roll a number cube, spin a spinner. Do those two things affect each other? Absolutely not. Therefore, they are independent. But if you pick a flashcard and then another flashcard, when you remove that first flashcard, you now have one less flashcard than you did before. In this case, now we have 29 cards. So those are dependent events. All right, how do we find the probability of independent events? So this would be independent because if you read the question, you're talking about drinks and chips. The kind of drink you pick and the kind of chip you pick are not going to affect each other. It doesn't matter what kind of drink you pick to change what kind of chips you get. So those are independent events. If you look, I had to find the probability of the diet drink. So if you go through the problem, you find out there's 10 diet drinks out of 15 total drinks. That was from last section, how to find the total. And then there are 8 fat-free chips out of 20 total chips. Since they're independent, we're going to multiply those two things. Oh, sorry. And also, this is an and problem, drink and chips. So we're going to multiply them 10 out of 15 for drinks times 8 out of 20 for chips. Multiply across, put that in your calculator, and you get 26.7. All right, let's talk about mutually exclusive. What does it look like to be mutually exclusive? So if we take a look here, when it says if you roll a 2 and a 3, those have to be mutually exclusive. You cannot roll a 2 and a 3 at the same time. You'd have to have 2 different rolls for that. But could I, in one roll an even number and a multiple of 3? Absolutely. If you get a 6, that number is both even and a multiple of 3 in one roll. So those would not be mutually exclusive events. All right, so here we go, probability of mutually exclusive events. So if we look at this particular problem, it says very strictly at the very beginning of the problem, you can only take one foreign language each term. That means you cannot take French and Spanish at the same time. That's what makes this mutually exclusive. That cannot happen at the same time. So they gave us our 2 probabilities. We're going to add them together because we are taking Spanish or French and they're mutually exclusive. So we're just going to add those 2 probabilities together. Finally, if we look at this problem, we're talking about round or green. So I know I have to add them because it's an or problem. But if you look over here in the little picture, you'll notice there are some that are round and green at the same time. So those are not mutually exclusive events. You could be both round and green. So that means that not only are we going to add our probabilities, but we're also going to subtract the amount of times that it happens that they are both round and green. So the amount of items that are round is 5 out of 9. The amount of items that are green is 3 out of 9. But there are 2 items that are round and green, so I'm going to subtract that overlapping period. You do all of the numerators together, 5 plus 3 minus 2, you get 6. So that's our answer of 6 nights. All right, here's what I want you to do for today. I want you to go through and do these matchings, all of them. So A goes with B, A goes with B. See if you can match those things up. It'll just give you some more examples of independent versus mutually exclusive, etc. And then I want you to go through and try this quiz and see if you can come up with the 5 answers on this page. Those are going to be your points for today. Remember, you're just doing them in your OneNote notebook. You don't have to do them anywhere else.